Good afternoon to one and all present here. I am Dr. Alok Agrawal and I will be taking your course Fluid Mechanics having subject code ME404. So in today's class, what we will do, we will discuss about the course. We'll see the syllabus of the course and the important books that you need to refer in this course. Then we'll move into a unit 1 where we will see what is fluid, is the difference between solid and fluid, and what are the difference between liquid and gas. As both are fluids, we know liquid and gas both are fluids. So what are the basic difference between liquid and gas? So these are the content that will be covered in today's video. So subject code is ME404, subject name is fluid mechanics, and it consists of theory as well as practical. Theory and SEM will be of 70 marks, mid-SEM will be of 20 marks weightage, and there will be 10 marks for quiz and assignments. Under practical, there will be 30 marks for NSEM and 20 marks for lab work that we will be going to do in the semester. So total it is of 150 marks having a credit point of 4. In syllabus again, this fluid mechanics is divided into 5 units. The first unit is about fluid static, followed by fluid kinematics, fluid dynamics, then fourth will be flow through pipes, and unit 5 will be about boundary layer theory and compressible fluid. So we'll discuss each unit or the terms that I have used in detail in coming classes. Now coming to the important books. What are the important books that are associated with this subject? The first one is by B.S. Massey, that is Mechanics of Fluid, followed by Fluid Mechanics by Shames. The most important book that I suggest you to prefer is a textbook of Fluid Mechanics and Hydraulic Machines by R.K. Bansal. You can also refer R.K. Rajput, Fluid Mechanics and Hydraulic Machines. So these are the important books. I will be referring second and third number books like Fluid Mechanics by Shames and R.K. Bansal most of the time. So you can refer all the 4 books or you can refer any 1 or 2 books to study. Now coming to the introduction part of the subject. So we know that every substance can exist in 3 different phases, that is solid, liquid and gas, that we have already studied in our school. A substance in liquid or gas phase, we called it as a fluid. So out of these 3 phases, 2 phase liquid and gas comprises and it is said as a fluid. So what is fluid? So till now, the basic definition of fluid that we know is that a substance which has ability to flow, we called it as a fluid. But engineering definition is little bit different from the above definition. What engineering definition says that a fluid is a substance that deforms continuously when subjected to a tangential or shear stress, however small the shear stress may be. And because of this, there will be a flow of substance. Okay, so though you will find this definition to be very complicated, I will try to explain the definition that what is happening in solid. Suppose this is a solid and this is a fluid. This is the element of fluid and this is the element of solid. When we apply a tangential force to the solid element, what happens to it? It will deform. There will be angular deformation. It will fix it from downside and we will give tangential force here. We get a deformation and this deformation depends upon the magnitude of the force. As we increase the magnitude of this force, the angular deformation will increase. Okay, but what happens in case of fluid? When we apply a tangential force, however small the tangential force will be, the fluid element will deform. It will undergo angular deformation and that deformation continue to grow until and unless we are not taking the force out from the system. Here again it is written this thing only, that a fluid is a substance that deforms continuously. It will deform continuously till the force is applied when subjected to a tangential or shear stress or force, however small the shear stress may be. Means it does not depend upon the magnitude of force. It depends that if we are applying the force, the element will deform, and that deformation will go continuous until and unless we are not going to take that force out of the system. And this continuous deformation cause flow, constitute a flow, and because of this property only the fluid has ability to flow. Okay, so let's come to the basic difference between solids and fluids. And when I am saying fluid, it is for liquid as well as gas. So in solid, the molecular solid are closely packed as compared to that of fluid, that we know, and the attractive force between the molecule of solids are much larger than those of the fluid, that we have already been seen in our school education. Okay, distinction between solid and fluid is made on the basis of substance ability to resist an applied shear stress that tends to change its shape. Now this is a engineering definition, or we can say that this is the difference between solid and fluid in engineering term. Okay, so if there is a substance and if that substance resists the applied shear stress, we put that substance in the category of solid, and if that substance does not resist the applied shear stress, we put that substance in the category of fluid, that we have seen in earlier slide. When we apply a small shear force, if there is a solid, it will not deform. We have to increase the shear force up to a limit to make it deform. And when we stop applying the shear force, either it will come back to its original shape or it will be like that only. But in case of fluid, if we apply a shear force, however small it may be, it will not be able to resist the shear force, and it will start deforming, and the deformation continues till the shear force is applied, though we are not increasing the magnitude of the shear force. A solid can resist and apply shear force by deforming, whereas a fluid deforms continuously under the influence of shear stress, no matter how small. That already been explained. In solid, stress is proportional to strain. See, in solid, when we are applying stress, it is proportional to the strain. Means if we increase the stress, the strain will increase. If we decrease the stress, the strain will decrease. But in fluid, it is not the case. When we apply shear stress, it is proportional to the strain rate. Means strain depends upon the duration of application of stress, not on the magnitude of that stress. Okay. So this is the difference. When we apply force to solid, it will deform and it will remain in that position when the magnitude of force is not changed. But even though we are not changing the magnitude of the force, the deformation continues and it will grow like this. So this is the basic difference between solid and fluid. Now we have seen that this fluid are categorized as liquid or gas. So let's see what is the difference between these two. In liquid, force of cohesion, or what we call as a intermolecular force of attraction, is relatively stronger, though it is less than solid, but it is greater than gas, whereas in gas the force of attraction is weaker. Next difference is liquid is difficult to compress and it considered as a incompressible fluid, though it is not perfectly incompressible, but we in our study, in most of the cases, we consider liquid as an incompressible fluid. But gas has a property gas has a property that it is compressible in nature. We can compress it with a very little amount of force. Okay, so this is the important difference between liquid and gas. Again, liquid occupies fixed volume and will take the shape of the container. We have seen that if we put water in a glass or in a bottle, it will take the shape of the container. But what is the case in gas? It has no fixed volume. It will expand and it will fill the complete vessel. If we put a gas in a small box, it will fill that box, and it will increase the size of the box with same amount of gas, then it will increase its volume and fill the complete bigger box as well. So it has not a fixed volume. Again, very important difference between liquid and gas that is very much important in our engineering application is that in liquid there is a free surface. A free surface is formed if the volume of container is greater than the volume of liquid. But at the same time, there is no free surface in case of gas, because gas always completely fills the vessel on which it is kept. Okay, so these are the basic difference between liquid and gas. So this is it for today's class. We will discuss in next class the various properties of the fluid. Thank you very much.